All right, everybody, hello and welcome. Today we're going to be working on 6.6, which is trig equations. So for the first time here, we're going to be solving for some unknowns, basically moving stuff around the left and right side using the unit circle. So unit circle right in front of you on the home screen here. Just a couple of important things to remember. Number one, you want to have a unit circle in front of you because that will make your life a lot easier. Number two, sine is y, cosine is x, and tangent is y over x. So as you're going through and as you're solving these, you'll want to keep those three things in mind, and that will go a long way when you're going and searching for values as you work through the unit circle questions. So I'm going to be flipping back and forth between the unit circle as we do the notes today, and I'd suggest that you do the same if you have some of those. So like all equations, we're just trying to find the value that makes the equation true. So if you see a value given to you, you're just searching for where is that statement a true statement. So looking for angle specifically in this case when they give us values for a function. So if we take a look here at cosine of root 3 over 2, and it's specifically saying within one rotation on the unit circle. So we're not going more than 360 degrees. We are specifically looking for the value root 3 over 2. So important to remember that cosine of an angle that is equal to the x value on the unit circle. So what that means is we're going to have to jump over to the unit circle and look for all of the places where we see root 3 over 2 as the x value. We do have to keep our sign in mind as well, so it's not all root 3 over 2, it's where it is positive root 3 over 2. So if we're looking for that here, we can highlight the areas where that's true. So we have an x value of positive root 3 over 2. Should probably make it so you can actually see. And that'll be at 30 degrees or at pi over 6. And then the only other positive root 3 over 2 that we see is at 330 degrees. We do see it come up negative, and that does not work. So I'll put it in red because this is not part of our answer. Negative root 3 over 2 does not work at 150 and 210. So the answer to this question is 30 degrees and 330 degrees. Those are the two places where we see that cosine is equal to root 3 over 2. So one thing to keep in mind is this is just for a single rotation on the unit circle. If we were rotating in a negative direction, if we were rotating more than one time, we'd have to go through and search for more values, but in this case we are lucky because it's just one simple rotation around on the unit circle. So questions do get slightly more challenging, but the concept still applies. So for our question here, we're looking for when does negative 2 times the sine of x equal 1 on the interval 0 to 2 pi. So this is in radians. And it's important to note 0 to 2 pi is the same thing as 0 to 360. 2 pi is a full rotation on the unit circle, so still just looking at a single unit circle rotation. So the first thing that we're going to want to do here for the negative 2 sine x equals 1 is we're going to want to get sine by itself. So solving for x just like we normally would solve for x. So we'll divide by negative 2 on both sides because that's negative 2 times the sine of x. And then we'll be looking for where do we see negative 1/2. Now important to keep in mind that when we are solving this, we are looking for a y value of negative 1/2. So if we have a y value of negative 1/2, that is where we're going to see that this is true. So a y value, negative 1/2, back over to the unit circle. And I'll circle this one in blue. So y, negative 1/2. Is going to be right here and right here. So at 330 and at 210 are going to be the two places that we'll see this. The one thing that we want to remember here, though, is that we are working in radians. That was what the interval was given to us in. So instead of 330 and 210, we actually want to use the radian measure given. So 7 pi over 6 and 11 pi over 6, because that is the unit that we are working with here. So back over here, we're going to see answers of 7 pi over 6 and 11 pi over 6 as well. So again, if this rotated more than a full time, we'd have more work to do, but we don't because we are here, we're happy, we did everything that we need to do for a single rotation. So the final question here on the first page is asking us what would happen if we did more than one rotation. And the answer is that it stays in the same location, but it's another rotation. So we'll write that down. We'll say same location on the unit circle. We just have to add a rotation. So by adding a rotation, we can be very specific. That means adding a 360-degree rotation, or if we're in radians, that means adding a 2 pi rotation. If you go in a negative direction, you would obviously subtract those to go the other way around. The important thing to remember here is every 360 is another value. So let's say, for example, our first question had values of 30 and 330. If we wanted to know where they would lie, if we went from an interval of 0 to 720, so as 2 rotations, we would just add 360 to each value, and we would get an answer of 390. We'd also get an answer of 690 for each of those. So our 4 answers for this interval would be 30, 330, 390, and 690 if we were to look at question number 1 from the perspective of 0 to 720 degrees as our interval. So that'll come up more on the next page. So with that, we can flip over to page number 2. So cosine squared equals 3 over 4 on the interval of 0 to 2 pi. So again, a nice one, just one rotation here. And we still have to do our solving. So we have cosine to the second power, so that means that we're going to be taking the root of both sides of this equation to get just cosine. And then that'll end up with root 3 over root 4. And we can simplify the square root of 4 into 2. Important thing to remember with square roots, though, anytime you take them, it is the positive and negative square root. So 2 times 2 is 4, and negative 2 times negative 2 is 4, which means that we are looking for, on the unit circle, where do we have positive 3 over 2, or where do we have negative root 3 over 2. So if we're doing both of those things together, we're searching for each of those values as we go across the unit circle. So cosine, again, looking for our x value. So an x value of root 3 over 2 on the unit circle. So if we look for that, I'm not going to flip back and forth for this one because we get the idea, but look at the page in front of you, and you're going to see that there are 4 places where we see positive root 3 over 2 or a negative root 3 over 2 for the x value specifically. We are in radians, so we want to make sure that we have an answer in radians. So we're going to have x equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So 4 different locations, 1 in each quadrant with a root 3 over 2. For the second question here, this is where it gets slightly more complicated for us because we are not given an interval. So if we're looking for 2 cosine plus root 2 equals 0, it does not say an interval, and if it does not give an interval, we have to solve for the infinite rotations. So we have to be ready for any number of times that we go around the unit circle. So here, again, setting this up to get cosine by itself, we'll subtract the root 2 from both sides. We'll have 2 cosine x equals negative root 2. 2 times cosine x, we'll just divide to get cosine by itself. So we're left with the cosine of x equals negative root 2 over 2. So for this example, it doesn't specify if it's degrees or radians, so we have a choice here. We're looking specifically for an x value of negative root 2 over 2, and we see that that is going to come up in 2 specific places. So the first place is at 135 degrees, and then the second place is at, where is it? 225 degrees. And now the challenge is we have to solve for an infinite number. So we obviously are not going to infinitely write down all of these values, but what we actually do is we add a plus term in here, and we're going to say plus 360 times k, plus 360 times k. And in this case, k equals the number of rotations. So if it's 0 rotations, we're just on the first time through, it'll be 135. If it's 1 rotation, it'll be 135 plus 360. If it's 2 rotations, it'd be 135 plus 360 times 2, or 135 plus 720. So to be more specific, some values that we have, some actual answers if they want discrete values, we can solve, basically make a table for k value and for our x value. So when k equals 0, it's 135 plus 360 times 0, which is just 135. When k equals 1, 135 plus 360 times 1, which would give us 135 plus 360 times 1, 495. Do it for 2 rotations as well, so it'd be 135 plus 360 times 2, and that would get us 855. And you just keep going for all of them. So that is for our first one. You'd also want to do the same thing for your second table as well. You'd have to make a second table with 225 as your starting point instead of 135, but basically plugging in values and going from there. If you have a TI 80 series calculator, you can plug in these formulas, go to the chart view, and it will spit out the values for you as you work through them. So that is the first half of this. I do want to make sure that we do an example in radians. So instead of 135 and 225, we could also say that x is equal to 3 pi over 4, and x is equal to 5 pi over 4. And when we're doing our rotations, instead of adding 360 times k, a full rotation in radians is 2 pi. So it'd be 2 pi times k for each of these. So each time you go around the circle, you add an additional 2 pi to your term. So you do the same thing. You would make your chart. You would have k, you would have your x value, and you would start off with 0, 1, and 2. So you'd have 3 pi over 4 for the first one, plus 2 pi times k, 2 pi times 1, 2 pi times 2, and it'd be the same steps for solving. The only tricky thing with radians is you do have to deal with fractions. Just remember that 2 pi as your common denominator, you could set it equal to whatever it is. So in this case, you could have 8 pi over 4 instead of 2 pi, and that will keep things simple for you because your denominator for each of your fractional terms is the same, and that might help you when you go in and plug in these values. So we can go over a few more examples to make sure we have some practice. So on page number 2 here, the last one that we have deals with cosecant, which is a mean one. So first steps first, always want to get our function totally by itself. So we're going to add 3 to both sides. So we'll have 5 cosecant theta equals 5. Divide by 5 to get cosecant alone. We'll get cosecant equals 1. And then on the unit circle, we have to remember that cosecant partners up with sine. And in this case, sine is y, so cosecant is equal to 1 over y. So if we're looking for 1 over y, we can set this equal to 1 is basically what we want our answer to be. So we can basically get a value of y is equal to 1 is what we are looking for. So back over to our unit circle, we're looking for the exact term, the exact location where y is equal to 1. So in this case, we would be looking for just 1 point, and that's going to be 90 degrees, or we can also write that as pi over 2. But it gives us our interval in degrees, so we'll keep it as 90 degrees, so a y value of 1. So inverse trig functions, they work the same. We just have to go back to our definitions. We just have to know that cosecant is 1 over y. And as long as we know that, we will be in perfect shape to be able to go through and solve here. So more practice on the final page here. I'll post the answers to that in Canvas if you want to look through and see how you did. But basically all that we're doing today is just doing some unit circle searching. So if you can find the value that you need, all you're going to do is just look around on the unit circle, look for that rotation, and then you'll find the exact value for the final answer. So as always, questions, let us know. Thanks for watching, and get started on those practice questions.